This video is the installation instruction of 145 kV cable joint from Changlan Electric Technology Co. Limited. Joint main body, constant force spring, equivalent pressure sleeve, ferrules, copper protective shell, heat shrink tubes, cable tapes, epoxy mud. First installation preparation and precautions. Check whether the model and specification match the cable, whether the parts and supporting materials are complete, and whether there is any damage. A construction site with a length of at least 8 meters and a width of 3 meters shall be reserved at the construction site. Please watch the preparations and precautions on the screen or on the installation instruction. Determine the phase sequence of the connected cables and cut the two cables with the same phase sequence to flat and straight. Determine the center position of the joint and saw off the excess cable at the two cable ends from the center of the joint. Please note that there should be a certain overmeasure for the cable at the joint. 2. Stripping cable outer sheath and metal sheath, removing graphite layer. Measure 1000 mm and 870 mm down from the end of cable 1, and 640 mm and 510 mm down from the end of cable 2. Use PVC tape to temporarily mark them, and peel off the outer sheath of the cable between the two marks. Clean the metal sheath of cable 1 and cable 2, respectively. Strip off the outer sheath and metal sheath of cable 1 and 2 with a length of 870 mm and 510 mm, and arrange the metal sheath fracture into a belt mouth, and remove below the outer sheath fracture. Graphite layer 300 mm long. Use a file to polish the 80 mm section of the metal outer sheath above the end of the cable outer sheath, and in it. Tie 7 copper braid with a length of 400 mm and cross-section of 35 mm to the tin-plated parts of the metal outer sheaths of the two cables and weld them firmly. Note: when sawing the metal outer sheath, the thickness should be 2/3. Do not completely saw through to prevent the cable insulation from being damaged. Heating temperature should not be too high, time should not be too long, just to be able to solder, to prevent burning cable internal insulation. 3. Heating and straightening cable. Wrap heating tape from the metal sheath end. Heat the cable with continuously 3 hours 75 to 80 degrees to eliminate the mechanical stress. After heated, remove the heating tape. Clamp the cable straight with a workpiece such as angle aluminum to ensure that the cable is not bent after cooling. Note: when heating and straightening, the heating temperature should not exceed 80 degrees, the time should not be too long, the clamping force should not be too large to prevent cable damage, and appropriate protective measures should be taken when necessary. 4. Stripping outer semiconductive layer and core of cable. Strip off the two semiconductive buffer layers of the two cables, and temporarily mark the place with a thickness of 30 mm from the ends of the two cables with PVC tape. Use a glass sheet to carefully scrape the mark to the end of the cable and the outer semiconductive layer of the cable. The sections are arranged into small slopes of 20 to 30 mm long, and 88 mm long cores are stripped from the ends of the two cables. Use coarse sandpaper to polish the slope to ensure a smooth transition with the main insulation surface. Use 320 and 600 sandpaper to polish the cable insulation. Note: no puts or steps are allowed at the transition. When exploiting semiconducting, it is not allowed to use semiconducting knife or insulating knife. Only glass plane or special planer can be used to scrape carefully. The grinding section shall be very smooth. The stripping size of the outer semiconducting layer must be strictly controlled within a range of process requirements. Do not polish the cable insulation after polishing the semiconductive and core sandpaper. The stripping size of outer semiconducting layer must be strictly controlled within a range of process requirements. Clean the insulation and semiconductive layers of the two cables, blow them dry, and finally wrap a layer of cling film on them to temporarily protect the cables, and wrap a layer of PVC adhesive tape on the cable core. 5. Assembly of components. Measure and record the outer diameter of the main insulation of the cable in the orthogonal direction and the inner diameter of the joint main body to ensure that the inner diameter of the joint main body is 6 mm to 14 mm smaller than the outer diameter of the cable insulation. Note: the difference of main insulation outer diameter in orthogonal direction shall not exceed 1 mm. The inner diameter of the joint main body is 6 mm to 14 mm smaller than the outer diameter of the cable insulation. Put a small heat shrinkable tube, a large heat shrinkable tube, a copper protective shell, and a sealing ring on a cable first, and then put a small heat shrinkable tube, a copper protective shell, and two small heat shrinkable tubes on another cable. Note: cover copper protective shell with conductor connector on exploitative cable of longer size, and check that the seal ring must be carried in the seal groove of copper protective shell. Remove the temporary protection on the long end cable. Put the guide cone into the cable cord, clean the cable insulation, the outer semi-conductive surface, the guide cone and the inner surface of the joint main body with a cleaning towel, and blow dry. Apply a layer of silicone oil evenly on the cable insulation surface, the outer semi-conductive surface and the inner surface of the joint main body, and use the lever hoist tool to cover the joint main body on the stripped longer cable until the cable insulation end is exposed. Notice: only absolute alcohol is allowed to clean the joint main body. Remove the temporary tape on the cable cord. Polish the surface of the two cable conductors with coarse sandpaper. Connect the ferrule after cleaning and drying. After confirming that the conductor is inserted in place, insert a 200 mm long copper braid into the ferrule. Then select a suitable die mold and crimp it. Polish the indentation, sharp corners and glitch on the surface of the ferrule. Clean the surface of the ferrule with a cleaning towel, and blow dry. Connect the copper braided tape and the equivalent pressure sleeve with screws. The copper braid tape should be completely covered by the equivalent pressure sleeve. Then wind a constant force spring around the depression in the middle. Finally, wrap 2 layers of PVC tape on the constant force spring. The PVC tape should completely cover the constant force spring, but the tape should not be higher than the outer surface of the equivalent pressure sleeve. Measure the length of the overall joint main body that has been sheathed on the cable. Then measure the distance between the insulation ends of the two cables. The value should be less than 216 mm. Remove the temporary protection of stripped and shorter cable. Measure 1/2 the length of the overall joint main body from the center of the two cable insulation ends to the shorter section of the cable, and use PVC tape as a positioning mark. Clean the surface of the cable insulation and the surface of the equivalent pressure sleeve and blow dry. Apply a layer of silicone oil evenly on the surface of the cable insulation and the surface of the equivalent pressure sleeve. Use a lever hoist to pull the joint main body to the center of the joint to ensure that the end is flush with the positioning mark on the cable. Six. Shielding. Wrap 2 layers of waterproof tape around both ends of the joint main body to strengthen the seal. Wrap a layer of semi-conductive tape from the fracture of the two cable metal shields to the stress cones at both ends of the joint body and fill in the steps at the stress cone dot starting from the insulation section of the joint main body. Wind a layer of lead tape to the fracture of the cable metal outer sheath, and then wind a layer of copper mesh of the lead tape from insulation section of the joint main body to the end of the cable metal outer sheath. Then tie the lead tape and copper mesh with copper wire and weld them to the cable metal sheath. Starting from the insulation section of the joint main body, wind a layer of lead tape to the fracture of the metal outer sheath of another cable, and then wind a layer of copper mesh of the lead tape from the insulation section of the joint main body to the outer metal sheath. Then tie the lead tape and the copper mesh with copper wire and weld them to the metal sheath of the cable. The metal tape and the metal sheath are required to overlap by about 30 mm. Then wrap around the insulation section of the joint main body within a width of about 110 mm with self-adhesive insulation tape. At the same time, fill in the steps of the insulation section and the stress cone. The insulation section is covered by no less than 200 mm and A layers. 7. Install the copper protective shell. In the center of the joint, heat shrink to 200 by 800 heat shrinkable tubes. The two ends are overlapped with a metal sheath for about 50 mm, and the middle overlaps naturally. Then wrap 2-3 layers of waterproof tape around the overlap. Apply RTV silicone on the sealing ring and put it into the sealing groove of the copper protective shell. Then apply a layer of conductive paste on the end face of the copper protective shell flange of the grounding pole. Assemble the copper protective shell and fasten them together with screws. Wrap the filling tape around the metal sheaths at both ends until the outer diameter is close to the inner diameter of the copper protective shell port. Move the two copper protective shells to the middle of the joint, and adjust the position of the copper protective shell so that both ends of the copper protective shell are evenly overlapped with the outer sheath of the cable or the metal sheath. Note: the two paste filling holes of the copper protective shell must be directly above, and the copper braided belt must extend from the two ends of the copper protective shell. Fold the copper braid tape extending from both ends of the copper protective shell in turn, and tie the copper wire to the ends of the copper protective shell and weld them firmly. Mix the epoxy mud to component evenly and apply it evenly on the end of the copper protective shell. Then wrap 2 layers of waterproof tape to ensure that the copper protective shell and the outer cable sheath are respectively covered by at least 50 mm. Move the two small heat shrink tubes to the ends of the copper protective shell. Heat it to shrink and make sure that the heat shrinkable tube covers at least 50 mm of the outer cable sheath. Apply epoxy mud to the joint of the two copper protective shell flanges, and it is required to completely cover the exposed metal part and overlap the insulation layer at both ends by about 20 mm. Then wrap 2-3 layers of waterproof tape on the epoxy mud, and overlap 20 mm with the insulation protective layer. Pour the mixed 80-16 resin into the copper protective shell until it is full. Wrap 2-3 layers of waterproof tape around the glue opening. Seal the port well. Move the large heat shrink tube to the center of the joint. Ensure that the heat shrink tube covers the copper protective shells at both ends. Heat and shrink. The two ends of the heat shrinkable tube are wrapped with 2-3 layers of waterproof tape. Finally, wrap 1 to 2 layers of PVC adhesive tape outside the waterproof tape to strengthen the seal. 8. Connect the grounding cable. Strip the grounding cable according to the installation size. Tie the outer conductor of the coaxial cable into a bundle. Wrap for 2-5 layers of waterproof tape from the bifurcation to the 1/2 L plus 5 mm of the outer conductor end. Put the branch glove on the cable branch. Heat and shrink from the root to the ends. Wrap 3 to 4 layers of waterproof tape around the end of the branch glove tail tube, and 30 mm overlap with the cable and the branch. The waterproof tape is wrapped with 2-3 layers of PVC adhesive tape to strengthen the seal. Put 2 small heat shrink tubes into the 2 branch cables respectively. Connect the inner and outer conductors of the coaxial cable with the 2 grounding poles of the copper protective shell with a grounding ferrule and crimp. After crimping, polish the sharp burrs at the indentation. Use 2-3 layers of insulation tape to fill the gaps at both ends of the grounding ferrule. Wrap 2-3 layers of waterproof tape on the insulation tape. Respectively overlap with the end of the grounding cable and the insulation sheath of the grounding pole not less than 20 mm. Wrap 2-3 layers of PVC adhesive tape on the waterproof tape to strengthen the seal. Move the heat shrink tube to the crimping point of the grounding ferrule. One end is flush with the grounding pillar insulation layer step, and the other end is naturally overlapped. Heat it to shrink. Wrap 3 to 4 layers of waterproof tape around the end of the heat shrink tube. The waterproof tape is wrapped with 2-3 layers of PVC adhesive tape to strengthen the seal. The grounding cable is effectively connected to the grounding network through the relevant grounding device. and the cable joint without glass fiber box is installed.